What's wrong there? There we go. Right, what's it do? Right, welcome everyone. How are we doing? Welcome back. Oh, my headphones are downstairs, so I can't enjoy the good music. It's gonna be too warm anyway. Cool. Yeah, so exciting stream today. We finished up on the input code now, so we've got gamepad support. So we've tested PS5 controller, Xbox 360 controller, and PS4 controllers. So we're done with that, which is good. So it means from the code that we write from now on, we can support these controllers in there and just use a controller while we do some work. It's quite nice. So I just pulled in the changes from the Windows build that we did, or the past few streams. I guess three streams, maybe four. And that was about 1,500 lines, well, 1,600 lines of code. It's quite a bit. And then I just did a count lines of code on the project. For 27 episodes we've written about close to 9,000 lines of code. So fair play. So yeah. So I do briefly. So we've got to start off today by getting this build working again on here, because we probably have. There's a couple of functions we probably have to implement, but they should be super quick. But I just quickly want to mention that I did do a little bit of work, a tiny bit of work to get the window moving in Windows. So in Windows, the problem is our game window it would crash. So if we were to run the game, if you were to move the window around like this on Windows, it would crash. Or if you were to resize as well. So I just briefly quickly want to run over like why that was and how we fixed it. So I've just fixed it offline basically. So inside source OS windows.c, os windows.c. So in that event handler, that window procedure, I guess, I don't know what it's called, but it's that callback function which handles the things. Basically, so when you're in, so every time we call poll events, we then do this sort of peak message, and if we have any messages, we then translate the message and then dispatch it, right? Now the problem is if one of these events is you moving the window, basically Windows will stay. It will never return from this dispatch message because it like takes control, and it like basically has a loop that it keeps going around, and when it won't return while you're moving the window, but it will keep firing mouse events and things like this. So what's happening is it was filling up this event queue that we have, and yeah. So basically, this WinProc thing would keep getting called, and we'll keep saying, hey, the mouse has moved, hey, the mouse has moved, while you're moving the window like this. Wait. While you're moving the window like this, it would keep doing that, and then it'll fill up the event queue, right? So all I've done, just to get around this problem for now, so it doesn't crash on Windows, is when you enter resizing or moving the window, we just set a boolean just to say, hey, we're doing that. And if we exit, we set it to false. And then we check the dimensions just to see if it's been resized. The moved one I've not done yet, and then if it has been resized, we call or resized. But and that means that we basically don't queue up any events while it's moving. And this is the temporary solution for now. So if it's been moved or been resized, we simply just discard the event basically. So yeah, that ought to be good enough. But yeah, so that's how we fix it. It's not kind of an optimization, but I don't know. It's kind of a work around because it just, if not, it's just crazy behavior. But yeah. Hey there, Akros, how you doing? Welcome. So that's all we did there. So all I want to do is try and get this up and running again. I don't think there's too much. It's just starting the main Cs. Press the F5s, and we are missing a thing. So we've changed the size of this. I think I fixed a bug, and in doing so, I buggered this up. Ow. Oh, I added a new gamepad action. So it's another... Oh, I don't even know anymore. So it's another 4... It's just difficult to work out. We could play the guessing game. 90. Still off. 94. Right, that fixed that. So then 96. Sweet. Hey there, Ikriz. Will this work on X11 and Wayland? It works on X11. Not to be confused with the social media platform. R&D proc and dispatch is Windows only. What do you mean as a whole? Yeah, Vim Creator is dead. It's a shame. Shame. He died quite young as well. 60 odd. He's in the retirement. That's it's not the best, is it? Awesome. Let's fix that. Yeah, so we are running on X11 right now. We're not running on Wayland. In the future, when we probably release this thing, Wayland is probably going to be on every main distro anyway. There's always one more problem with Wayland, and it's been like that for like 11 years. It's a bit like you're working on a feature and you just keep going. Oh, I'm nearly there. And then you just don't get done for so much more longer, right? Yeah, there's lots of... I think that it's been close, right? It's been close for so long. But yeah, we're just doing X11 for now because it's the stuff I know, basically. What happened to my keycode map? What? Why is it incomplete? Tell me more. Of incomplete type. OS keycode array. Right, we'll open it up in the terminal. Scripts, build, no release. That's for the compiler. Right. I don't know if I touched this code, did I? So the thing is this thing is declared. Wait, I know. Did I don't know if I moved stuff around, is that true? I'm not sure what I did, but... No, okay, here's the thing. When I was in the Windows development, I was doing this equivalent code on Windows, and I was like, hang on a minute, I didn't do the bounds check. So then I added the bounds check in, but the problem is this array isn't actually declared yet. It's been forward declared, but the size is not known. And the size is known here. Right. Okay. 236. That'll fix it. Identify E. EVDev keycode. Oh yeah. The poncho. No, it's just a top. It's yeah. Just my summer top. Right, now is one more function just to complete, and then we'll be back up and running. OS is debugger attached. I don't know how you do this on Linux. To figure that one out. Linux, check if debugger Linux C Linux is something like that. By GDB, exactly. That's what I want to know. Yeah, we could always just return true or false and put a to do in there if it's complicated, but maybe we find a good simple. Yeah, this is how you do it. Do a signal handler, raise a trap, and then like set it to 0 if it's, oh my days. No. Yeah, tabs all the way. You got to save those, three bytes per tab. Good savings. See, on Windows you have this, right? Basically, but on Linux, it might be. End up with using was the following. Right, so GDB check. So you fork the process, get the new process ID. So is it great running fork? That's a bit of a hack, that one. Yeah. You know, maybe we won't implement this yet because it's like, it seems like too much effort and I can't be bothered. There's probably a really good, elegant solution somewhere that we could find. It's the correct way, is it? Fair play. Hey Bubbles, hey Silvercore, how you guys doing? Welcome, welcome. How's things been? Yeah, ChatGPT is for all the newbies, you know? Nah. See, the problem with ChatGPT is it's kind of a bit like, you know, guaranteed they trained it all off of open source code and then it just regurgitates it. So I'm a bit unsure on like it's definitely a good tool, but I don't know. Like I'm just used to scanning the internet, you know. I would Like people use like Copilot, and it's like trained off of all these open source software that Microsoft just bought, like the access where they host them. And it was like, yeah, I'm gonna scan all these because I can. And it's like, that seems really unethical. Yeah, maybe we can do it this way, but yeah, I can't be bothered right now because I want to do other things today. I want to do what's in the title, you know. I want to like do some rendering, you know. So what we're gonna do? So we're gonna go to the Windows one. No, we're not. Right. So here's the OS Linux file. Right, it's got the Linuxy stuff in it. 1600 lines of code, and we're just gonna say return false. So the reason why we have this is purely just because when we crash the game, if the debugger is attached, we want to do a breakpoint. Whereas if it isn't, we'll pop open a GUI window and we'll just be like, oh yeah, the game has crashed. Check the stack trace file, and you see the thing, yeah. And if it's here, we probably want to do a print as well, the stack trace. But anyway, things can be made better, that is for sure, when it winds me up. To do, right, there you go, ta-da. Right. So what are we doing today? Rendering. Something I've noticed with ChatGPT seems very bad at statistics problems. Yeah, I guess because it is kind of like a bit of a blurry thing, isn't it? It's kind of like, it's a very complicated, it's a very like averaged, but the way it works is it's sort of like, yeah, it's very complicated. Not very simple. They can do some really incredible things though. A friend told me ChatGPT will output code that relies on non-existent packages and stuff like that. Really? I don't know if the AI hype has disappeared. There's definitely people still on it, but yeah, it did make me cringe for a good while. Like some of the technology that was cool, like all the images that were being made, and stuff like that. Um, but yeah, it definitely made me cringe though. Anytime I read something, because it was just like, oh, this again, this fad again, you know. Um, right. So if we run the game now, that's the thing. We didn't even try running it, and I was just like, oh, it builds. It must run, right? Well, we'll find out. I don't see no game. That was weird. Okay, we're here. So what we have right now is there is a shader printing out into the terminal. Because we've got printf in shaders, it's just printing out tons of pixels because it can. It's basically the image that you're seeing. So we've got three layers. We've got background, which is just a gradient, right? And then in the middle we've got some triangle, which is just a square compute shader that cuts out the triangle. And then the logo on top of that is a logo that's been rendered, and we basically test to see if the background is black, and then we discard it. Obviously not the most amazing stuff, but it was there to test out the GPU API that we have, and it's all going to get rid of today. We're going to get rid of it all because we're going to do some UI rendering. So, hey there, Code Slasher, welcome. Welcome, B Sharp, welcome. Yeah, I'm doing good, man, I'm doing good. Busy day. Went and bought like 26, 27 liters of soft drink, you know, because we're doing like a party on Sunday. So we bought so much soft drink, it's insane. And just been looking after the baby. Also managed to find some root beer, which we don't really have in the UK, and I found some, so I was happy. Got some root beer. Oh, I got this. My wife's mum went to Kenya, and she brought this back with me. So yeah, it's a t-shirt. What's the party for? It's for the It's for the baby, basically, to celebrate the baby's birth. Um, bum, bum, ba-dum, bum. So yeah, something about this project is we are doing entire rendering in compute shaders, partly for a challenge, and the other reason is that it's for simplicity. So if you take a look at Vulkan, super complicated, super crazy, half of it, or most of the craziness comes from the fact that it's got the traditional pipeline, which is basically a bunch of state that needs to be configured, and the state is in all these different objects that connect with each other and have all these rules and everything. But if you just use compute, you're just launching compute shaders. But it is limited, and it's kind of more of a low-level way of doing things. So you basically have to implement, like, it's really good just for crunching a bunch of data. But if you want to use it for like rendering stuff, you basically have to manually optimize things and lay things out in particular ways. So yeah, but in the grand scheme of things, it's made so we've got GPU API, which is basically our own OpenGL, right? So our own sort of like graphics API, and we made this in the first so many streams. Like it took us longer to do support for gamepads, keyboards, and mice across Linux and Windows than it did to do this thing. Partly because I've done this mostly before, but so we basically have the ability to make resources like create buffers and textures. We have the ability to then upload to those buffers and textures, read back from buffers and textures, so we can maybe make nice GIFs and stuff like this, animate GIFs. We got some extra bells and whistles which seem pretty cool. Like you can basically get the GPU to do some logic and produce commands for the CPU to then do. So we've just made a buffer which let's call it a readback command buffer, which allows the GPU to produce commands for the CPU to do. So this GPU is in control, right? Maybe it was an easy thing I could do, and I thought this would be interesting. So let's put it in, and it's all plugged in, ready to go if I want to use it. So if we're doing anything, it might come in use, it might not. Then this is our commands that get recorded into a command buffer. So you can start a frame, you can submit a frame, and then anywhere in between here you can dispatch compute shaders, and you can also sync on resources. So you put this before a dispatch and you say dispatch, and it will sync on the resources, so you don't have two dispatches trying to read and write to the same buffer and get in race conditions. And then yeah, so that's it. It's literally like 200 lines of code, and voila, you can do GPU things. So this is the thing we're going to be using. So we also have, I spent like a year and 3 months working on my C to SPIR-V shader compiler. So we also are going to be using, so basically we've got this single file here that we're compiling, gfx shaders.c, and we're running this through my C to SPIR-V. So see here, HCC, that's my shader compiler. So it takes in that file, outputs the SPIR-V file with all the shaders in it, and we've got some special fancy stuff like swizzling and some other things. But yeah, this uses the latest and greatest shader technology, basically. So effectively, we have these things called bundle constants, which are set up from the CPU side, and you can pass in data up to about 64 bytes. That's what we're going with for now. And every resource can be you can put resources in here, and that's basically a 32-bit integer. And so you can upload your resources as if it's data, and you don't need to have any bindings or anything like this. And then our compute shaders are obviously just here in C, but they're obviously only compiled in my compiler, not compiled in any other compiler. And so this is what we're going to be doing today, is using these compute shaders to do some UI rendering. That's the plan. Yeah, it's like a Nigerian type of thing as well. Yeah, exactly. Yeah, I've got some, actually it's got a new smart outfit for church when I go on Sunday. That's pretty cool. Yeah, all the African attire type of thing. So what we're going to be doing is probably just getting rid of all of this. So should we talk about how we're going to render UI? So, should we get the most basic thing working and then it'll be easier to go from there and describe. So let's get rid of, right, so we've got a, and then, yes, okay. So we're going to get a shader which is going to render one, we're going to write a shader which renders one rectangle and we'll put it anywhere. That's what we'll start off with today. And then we'll advance from there and make it more optimized and go with a full-blown thing. Okay. So radio. Hey there, Nico. How you doing? Back on the Unixes. Some people say that the market for tech is really bad at the moment. I don't know. Are you talking about those like tech as in those sort of like Silicon Valley type tech companies, or are you talking about like, I don't know? Because that's basically like the biggest anomaly in the world, right? And it basically like doesn't reflect lots of other companies, right? No, just tech in general, really? Apparently they're all self-taught. I didn't get it. Oh, there is no announcement in Discord, is there? Oh yeah. Whoops. Every time. I just get too excited, Ransel, you know, I wanna get going. Yeah, I can download Engine. I could also download RAM, you know. But I don't like downloading things. I could download more hard drive space, you know, all things, right? So, right. So where's this UI thing going to go? Let's start off with this. So the idea is the UI system. So we haven't got one yet. It's gonna make render commands, right? And then those render commands are going to be available for us on the GPU, and we're just going to render, right? So the idea is it's going to have a UI folder, right? It's got a folder. We'll do the whole shebang. Usually we do like a, well, it depends, right? But the idea is we'll do something like this, right? We'll have like a implementation file, a public header, an internal header, and then like maybe a shared header between the CPU and GPU. Right, yeah, we'll need those. So what we're going to do is we're going to cd into UI. I'm going to touch all over the place. We're going to touch UI.c, UI.h, UI internal.h, and UI shared.h. So shared means just shared between CPU and GPU. So what I want to do, I pressed the wrong keys, is open up just the shared one, because we don't really care about the others today, because we're focusing on the rendering code. So we pragma once that thing, and we're going to write out our commands that we're going to render, that we're going to use for rendering. And we're going to do a very simple shader, and then we're going to optimize it. So we're just going to call it UI. UI draw command. Now, remember this is shared between CPU and GPU, and guess what the GPU doesn't have? Unless you enable pointer support, it doesn't have support for unions. So we're gonna have to download a C compiler. No, I do have to download a C compiler, right? Because unfortunately mine is only for SpearV. But yeah. So different primitives, right? So we want to draw an axis aligned bounding box. We also might want to draw a circle, right? They're pretty good. But we also might want to draw like a rounded one, right? One where it's got like rounded edges. So what else could we want to draw? Maybe like an image. Or maybe, do you call it textures? And also you might want to draw like some form of glyph. Right, so these are the sorts of things you might want to draw. So we'll drop this thingy in here. Got to type. So effectively, yeah, you've kind of got to like generalize this into something. We might have a bunch of float params, or it doesn't really matter, to be honest. We could just have arg, like, we can just have like 4 args, because some of these got to be floats and that, but we might just simply reinterpret them as something else, and that might be fine. So then we might have like, we could just say 3 args at most. We might need, wait a minute. Yeah, because the biggest problem I have is we don't have support for unions. So you kind of might have to manually do it, but there are just going to be a bunch of these sorts of things. So A, B, 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 or B. You probably just need like a position. Right, so all of these are going to have a position. Probably in the center. And then they'll probably have the extent might be different, but a lot of them are going to have an extent. Well, to be honest, we could just say F32 center, and then we could probably do something like half size. So yeah, we could probably roll with that for now, and if we need to add any more, we can just add them. That's all we need. Hey King 440, how you doing? Yeah, back to sanity, back to lowercase letters. It's nice green tea here. Is it Rust style? I think people were doing it before Rust, right? People doing like U32, F32 before Rust. Nah, don't learn CPP, learn the C's. There's too much PP in CPP. Right, so basically we're just going to have a couple of these guys. We'll chuck them in a buffer, and then we'll run over them in the GPU, and we'll render some stuff, right? It's going to be dead simple, and you think we're done, but we won't be done. So the idea is we're going to have a buffer. So we're going to say UI shared. Okay, this is our shaders file. And we're going to have our lovely, lovely, lovely UI render. Right? So these are the constants that we pass up from the CPU to the GPU, and they're only 64 bytes, right? So we're going to be passing in a lovely read-only buffer, and this read-only buffer is going to be of type UI draw command. Isn't she amazing? And here's our draw commands. Now, delete all that because getting rid of everything else that we had here as example code is gone. Now this is specifically for the GPU. Yeah, we'll do 8x8 local size. Oh no, we need the clear. Shoot, I shouldn't have got rid of the clear. We need the clear. Crap. Give me a sec. Why don't make it so easy to delete code, you know what I mean? So we need frame initialize and clear. The other two can go. So frame initialize it just invokes one time, and it just initializes some buffers at the start of the frame on the GPU. So we've got a printf buffer, we've got a readback buffer, and they need to be initialized because they get modified over the lifetime of the frame. So basically, like the cursor is stored in the buffer at the start of where to write to next, and we atomically add. So this cursor sits at index 0 in the buffer. Yeah. So basically, we sort of like set the cursor to like 2, which is where the readback data can be written to. And whenever we want to write back into that readback buffer, we like atomically add to this integer at cursor index. And it's basically our cursor, which is shared across all the shader invocations. And that needs to be set back to 0 at the start of the frame, is all. Hey there, Eternal Divine Fox. Welcome, welcome. Doing good, thank you. Doing great. How you doing? Have you figured out the post Alder Lake business with the P&E cores? Yeah, I don't know. I don't think you have explicit control over those. I'm not sure. I remember asking someone and they told me the answer, but I kind of forgot it. But yeah, it does sound nice though. Not gonna lie, because I bought my wife a laptop a couple of years ago, and she's got one of those. And the battery life is quite good, and it just makes a ton of sense to have those sort of low power cores on a laptop. Not sure what it's programmed for though. Right, so we need to keep that frame initialized. We also need to keep the frame clear. So this clears the screen. Oh, we've not even done a proper good resolution. But yeah, it just clears the screen, just stores the texture. Wait, what are you doing? Oh, it makes the gradient. Yeah. No gradient. We just want it to be black. Proper rendering now. The rest of them we're gonna get rid of. All right. So yeah, notice here we just did a printf and we printed out the pixel color. So that got read back CPU side and we printed that into the terminal. But yeah, we'll get rid of that for now. So let's start a new shader. This one is going to be another compute. We'll have a local group size of 8x8. We'll get into more of the specifics of that later. And we're going to be using that. The input parameters are going to be right. So here's the bundle of constants that come in. So the idea is we want to. So we've basically got an array of these guys, and we kind of don't know how many there are. So we also need to know that. Draw commands count. How many of these little guys we got? So now we've got our friend the for loop. BC this thing. Cool. So the idea, we also need some output dimensions as well, just in case. So, right, I guess I'll quickly describe what's going on here. UI or render, sweet. So this is going to get launched across the whole screen. So if we open up the So right, so we're gonna have a screen basically, and so the local group size is 8x8, meaning that like, what's the best way to describe it? Yes, your local group size is kind of, you're better off. So it kind of depends on the hardware, but yeah, so we're just gonna say that this what's the best way of describing it? So our local group size is going to be like 8x8 pixels, imagine. And then when we launch this thing outside, yeah, let's describe it this way. So UI, all right. So we need to somehow do the draw commands. We'll figure that one out. Figure it out in a sec. Then draw commands count. Also, again, we'll figure that one out in a sec. Output dimensions, we'll hardcode that. Very nice, sweet. And then we're going to say, so there's the wind. We render to the surface. And so we're going to say we're going to write to that. And what we're going to do is we're going to launch the UI render shader. And then here's our launch parameters, basically. How many of these guys are we launching? So, why did it say 256? Right, what's the size of the screen? So I guess it's hard coded to 800 by 600 for now. Oh my days, this is bad. So we need to sort that out. Anyway, let's keep going. 800 by 600. There we go. So hit compile. So the idea is when we call dispatch, we're saying, hey, launch. So it's saying 800 divide, or like it's going to divide by 8, but it's a rounded up one, so it doesn't truncate, right? Divide that by 8 and divide this one by 8. So what we're doing is we're launching like 80. Oh wait, no, 80. How many of these are we launching? My maths is completely terrible. I'm so tired. 100. There we go. Maths. So we're launching 100 of these across the x-axis, basically. So there's 100 local groups being launched across the x-axis, and across the y-axis there's I don't know, less than 100 going down. So there's like 100 8x8 local dispatches being launched, basically, to render to the whole screen. So why are we choosing the number 8x8? I guess is the question. So the thing is, GPUs basically have like highly parallel processors in a way, and basically on AMD there's 32 threads in 32 threads and or 64 threads depending on the mode. It's called wave 32 or wave 64 mode, that run in lockstep, meaning they execute the same line, the same instruction on across all of the threads, because it's basically a SIMD unit, a really wide SIMD unit, and it can run in 32 thread mode or 64 thread mode, and it runs in lockstep. So if you pick 8x8, obviously that's 64 threads, right? But if you pick a number that's more bigger, like we could pick like 64 by 64, and that's going to run many waves, right? Many 64, many 32 waves in the same group. So all a local group means is that if you were to have some form of like dispatch group, like some it's called what was it called? Group shared memory in HLSL. If you had some shared memory between your group, like your local group can communicate with each other, basically. So you could have like some variable here, and like you could store in it for some reason in one of your groups, and you basically put a barrier in, and then the other groups can read from it, stuff like this. It's all a bit confusing, but essentially there's many different threads that can be running at different times within the same local group. But the reason why you would want a larger local group size is so that all those threads can communicate with each other. But it doesn't mean they're all running in lockstep together. It all depends on the hardware. So by picking 8x8, it could put, like, we could choose to make it run on a wave 64 on AMD or wave 32. Now NVIDIA only supports wave 32. It's kind of annoying, because there are like wave intrinsics which could be really useful for wave 64, but they don't scale up. So if you basically go to like GPU info, Vulkan, you can see this stuff. So you pick like an NVIDIA card, pick a 1080 for instance. You can go to properties, Vulkan 1, 2 maybe. And I think if you search for group, all right, 1.1 I think. Yeah, they're called subgroups. So a subgroup is like a wave. So it's only got a wave 32 mode. So there's only 32 threads running in parallel. So on, if you check like an AMD device, typically, I'm not sure about this one actually. This is a mobile one, isn't it, Vega? Oh yeah, so this has got subgroup size of 64. So if we were to pick, do something which does 32 threads, maybe 8 times 4, right? 8 across the X, 4 across the Y for some reason. That's only 32 threads. Meaning, on a Wave 64, like, GPU, you're going to have 32 inactive lanes when you run it. There's just going to be 32 that are inactive. So when you pick 8 by 8, you're going to be having it, it's going to, if it runs on those like Wave 64 modes, it will not have any inactive threads, right? So that's why we pick 8 by 8. Now on like an Intel card, they support all the way from 8, 16, 32 basically. I don't know where they have that, but there you go, Intel. Well, okay, these are 32 here apparently, but I remember seeing on some card, maybe it was the Arc or something, I don't know. I think they're Wave 32. But yeah, fair play. I'm not really too fussed about finding anything else, but yeah. So yeah, that's the reason why we pick 8 by 8. If you pick any higher, what's the problem with picking higher? Yeah, the problem with picking any higher is that because we've picked 8 by 8 pixels, right? Say if we pick 64 by 64 pixels. Well, what happens if you get to the end and this local group size only needs 8 by 8 or whatever, and the rest of them go off the end? Well, you've just spawned a whole bunch of, you've just had to spawn a bunch more waves to complete this group. And sure, they'll start and then stop right away, but it's still, they still have to be scheduled and go through the system. So when you're picking 8 by 8, it's a lot smaller, and it's basically the small, basically it's the smallest unit you can do, right? So yeah, that's the reason why I pick an 8 by 8, if that makes any sense. Yeah, because the thing is like when you see 8 by 8, people never describe like why they pick that number. Like what is this? How do you pick your local group size? You know. But yeah. Navi 31 GPUs have efficiency problem in Wave 32 mode. Really? Ooh. RDNA 3 can't issue function fixed. Wait, float multiply add in Wave 32 mode. Really? Wow. Fair play. Yeah. See, Wave 32 is great for really branchy code. Because it means you've got less inactive lanes when you're going over big branches. If it diverges on the branches, right? But yeah, Wave 64 is just a lot better for all those wave intrinsics. You can do 8 by 8 grids basically, or 4 by 4 by 4 grids, right? Because that all makes that's all a multiple of 64. Sorry, that all makes 64 threads, and you can do all these wave intrinsics without going to local the group shared storage, right? And doing barriers. But yeah, I don't know. It's just fused multiply add, right? Okay. Yeah, fuse into a single instruction. Nice. Right. So Yeah, so now we know we're going outside the. So we grab the coordinate from the dispatch index, which basically gives us the pixel, and if the pixel's outside the bounds, don't do anything. So obviously, if we made this thing a bigger number, as I was saying, this is where it would run here and then stop if it was to go outside. So you would get a waste on the edges the bigger these numbers are. So simply per pixel, we're just going to do the most simplest thing right now. Go over every single draw command and just render it. So let's fish out the draw command. So this is gfx UI draw command. Command equal. So if I remember correctly, we can just say bc draw commands index, pull that structure out, and then we can switch on here. So you might be like, a switch statement, isn't that really inefficient on a GPU? Yes, it can be. But it won't be so bad here. And the reason why it won't be so bad is because every branch is going to take every thread in this shader is going to take the same branch. So you're not going to have some threads take this branch and the other threads take this branch, because all of this code runs in lockstep. This is like the same, it's initialized the same, it's incremented the same on every thread, right? In like speed, if you just to look at the AMD hardware manuals, it'll basically go into an SGPR, which means it's a scalar register. So it's not shared across every thread. It's just the same across every thread. And because it's reading data which comes from a buffer using the same index, means this data is all the same across every thread, meaning that this is the same across every thread as well. So it all goes through the same thing, meaning there won't be any divergent lanes. If there's lanes which go over multiple things, the GPU will have to execute. So this could be a very big block for some reason. This could be a very big block for some reason. It would have to execute this one first and then this one afterwards. And basically it has to sort of make the lanes active or inactive depending on if the branch is the branch that they wanted to go down or not. And it will essentially like get rid of the values. The only downside is when you have the more branches you have, you could have the compiler could allocate more registers to be used. So we might, I don't know if there's ways around that without doing compiling stuff out, but effectively, like, because you might have to execute multiple of them. Yeah, it's got to allocate certain registers. So it could just it'll use up more registers basically because you're branching different combinations, right? So how are we going to draw these? So we're doing per pixel. How do we know we're inside an AABB? So an AABB is pretty simple. You could just check. You could just do a point verse box test, right? It's dead simple. So this one we can do really easily. Hey there, not so red. How you doing? Yeah, doing good, man. Doing good. Just been starting off on the UI stuff, and what else we've been doing? Just we'll also getting the code base back up and running as well. Just a few little bits, but yeah, things doing good. Went to the supermarket and bought like 27 liters of soft drink, So you got tons of drink for some party we're throwing on Sunday. But yeah, things are going good. It's also really humid here. Awesome. Good to hear. Good to hear. Yeah, so I guess we can start like dead simple and just be like, right, if So the thing is about these draw commands is we're just going to assume that they're in sort of like thing is, we've not accounted for any sort of form of order here or anything. Like there's a thing I want to end up in. Yeah. So I think okay. Let's assume they're in front to back order for some reason. Yeah. And the reason why we're going to assume front to back is... Wait a minute, do I have a color somewhere? I don't... Do I have a color thing? Like a color... No. Alright. U32 color. It's going to be amazing. Do we want like a shared color thing? RGBA 32 color, I don't know. Or just, it doesn't matter. It's hard to know what I'd name it. But anyway. So we'll just say like bool pass equal false, something like that. And all of these would say pass equal false for now. Something like that. And this one is then just going to say pass equal. So we've got the AABB data. So this coordinate is a... We'll say U coord. Then we'll make a float 32 version of it. Let's just call it coord. So I think we'll just say f3 times 2 splat 2 U coord. So splat just basically just says x, y. It just does like this, right? It does value.x comma value.y. And we just construct another thing like that. Just how we cheeky way of doing a conversion. So the pass is, so we've got the center position, and we also have the, so we just want to get like a distance basically. So you get your form of like diff. So we'll call it diff. So we're going to go coord sub take away command dot position. So that just gets you a difference from, so imagine you have your rectangle and we've got like a, yeah, we're checking a, yes. So you got your pixel, right? You got your center position. We're drawing a vector to it. Now all we have to do is say, is this vector less than the height and the width? And if it is, we're inside the box. That's all we're doing. So if diff dot x. So I do have like a less than f32. Wait a minute. We've got to do the absolute. ABS f32 times 2. So it just does gets the absolute value. Then you do less than equal f32 times 2 with is diff less than command dot half size. And voila. So if we pass, right, we are simply going to then have some form of color. So I want to have, so we're going to have like a color, imagine. See, for now I don't think we'll do any blending, but let's just hit there. So let's start the color off at probably yeah, probably black. Can't you group these commands by type? Yeah. Yeah, it's a party though. People can have a lot of sugar water. Don't worry, some of it's sugar free. Can I group these by type? Sure, maybe that might be better for branching. But the problem is I want to. No, they have to be like this. They have to be like this because of the way we're going to optimize it later. I'm just doing a simple version first. Looks like n to the power of 2 complexity. Um, yeah, at the moment, and this is what we'll be getting into, but we're just in the simple version first, right? This isn't the best code that we're doing. We're just getting something working, and we're going to make it better. But yeah, the problem that we're going to get to is that every time you add a new command, every thread on every pixel is going to run over all of your draw commands, and there's going to be a problem. So we're going to make that better. But yeah, no premature optimizations, right? Get work. But yeah, I've written it in a way where I know I can optimize it to what I want it to be at in a bit, but we're just going to have a very simple sample. So I guess we'll break initially. We're not doing any blending yet. So we'll just say, right, okay, color equal. So I've got a way to sort of like unpack unorm. Wait a minute, I forget this thing. So it's in my third party HCC intrinsics. We've got some intrinsics because they're built into like GLSL base or the GLSL basic library, which is part of SpearV. And we have a. Is that right? No, it's in the HMath stuff. So my maths library's got it. Which one is it? Is it part of Scalar? No, it's in vector. Right, so it's unpack. Yes. So basically, we want to unpack a unorm. Unpack U8 times 4 to F32 times 4. That's it. So you have a float. Yeah. So we're going to take in that color that we got, which is that 32-bit integer, which is basically 4 U8s. And we turn that into 4 floats. So we're just going to then bring that out and let's color and break. And then we're going to then store the final pixel at the end of the shader at that U coordinate with color. There we go. So let's get this thing compiling and see how it works. Command position. It's called center position. All times 2, damn it. All. Do we not have an output? Oh, we don't have an output. We need an output. We'll get to that. So the output texture is the surface, the Windows surface. Sweet. So the shader's compiled, because the shader's compiled first. Now it's got a couple of issues here. So we need our draw commands buffer. How are we going to get this? What we're going to do to create this? So we need to initialize one, that's for sure. So we're going to make a new resource. Resource means text draw buffer. So draw command UI, draw commands, buffer ID. Thank you very much. Create that. create buffer, initialize. What is the debug name? UI draw commands. How many bytes is it? Well, we want to be able to fit in size of UI draw command. Oh my days. Yeah, Phoenix wings. So we did have them initially, but then I took them out. Or I've disabled them because you basically need pointer support. And pointer support is available in Vulkan, but it's not available in well, it's available in Metal, but it's not available in DirectX. And I wanted to try and make it like I need to do a proper like pointer support thing as well. So currently I've got no pointers. Like I initially had them, but I've kind of disabled them because they weren't fully finished. But yeah, we just don't have them on right now. It's a bit of a shame, but yeah. Yeah, the unions in the shaders are a bit of a they're only on the CPU side, but we basically have swizzling built in and built into the compiler, so it gets around all of that. So it's the same syntax but implemented differently on the compilers. Oh, thank you. Appreciate it, Nico. Thank you, sir. Right, so how many of these boys are we gonna have? Should we say 32 for now? Really, no, really, we should put this somewhere. I don't know where I'm gonna stick it. GFX UI draw commands cap. So let's say I don't know. That looks like a good number. Okay. Boom. So we've created that now. So now we have to upload the data to it. So when you render a frame, where's the upload stuff? Yep. Right. So we start a frame. Here. So do some uploading. So upload texture, upload buffer, UI draw command. So where are we writing to? So the offset is 0, and the size, like how much we're writing to it basically. So we could, for now, let's just have an array. And we're just gonna have it like this for now. Wait a minute. Array count, draw commands, times by size of. Oh no, wait. Yeah, no, we will keep that because in future it will just come from an array anyway. Cool. And then we just want to do a super lovely mem copy basically. But we mem copy the draw commands in there so the GPU can have go at those. So I don't think they added it. They added physical address support, but that's only for ray tracing, right? But it means for something else, I think. Am I right by saying that? Yeah, if you can find it, please send me a link, but I don't think that's true. UI draw command A, B, B, because that's the one we got, right? So what color are we going to do? So it's kind of back to front, right? Is that right? Let's forget how it is. Yeah, so it's alpha, blue, green, red. Basically. So alpha for Leon. Let's just make it red, right? There you go. And then we want to say center position. So we've got 800 by 600. So let's just put it dead in the center of the screen. So center of the screen is obviously 400 by 300. Wait, I just realized. And then what sort of width do we want? So then we want a width of probably, I don't know, should we do 200 by 100? There we go. So now what we also want to do is kind of know how many draw commands there are. UI, draw commands, count, and then that would just be equal to this for now. Cool, so now we've got that all ready. We put the count in, and then we put that super nice draw commands buffer in. Ah, Perry boy, how you been? It's been a while. Yeah, things are going good, man. We're just getting back into some graphics programming. Starting off on some UI, obviously. And then we're building a whole UI system. But we got this bad boy working on Linux and Windows. A C was missing for the Windows streams. But yeah. How's it been? How you been, Perry? Missed you. Right, so we've got to convert this resource ID into an index. That's great for the GPU. It's using the indices to refer to. Okay. Oh. Right. Now let's see how much this doesn't work. Wait. We've got to run a poll. So you just saw what we just did, right? Pretty simple. So fingers ready, guys. Will it render a red sort of like rectangle in the center of the screen? Right, lots of... We'll just do 1 minute on this one. Lots of conditions, but you know, how well? Oh, I'm going to say it's highly likely there will be a problem. Because we haven't, but like, we did just copy paste and edit code, and it is simple, so it could be a yes. How ballsy are you guys? PS4 or PS5 controller? That's a PS5 there, Kappa. But yeah, we've got PS4, PS5, and Xbox 360 working. Or tested and working. How's mum little one? They're doing good. Oh yeah, segfault. That's another one, isn't it? Well, let's make sure that render function is being called. It'd be funny if I talked everyone into saying no. Oh, it's 50-50, 5-5. Hey, interesting. We've got half optimistic. Yeah. GPU crash, fourth option. Right, half of you are very optimistic, half of you are just kind of like realist, where it's like, oh yeah, it's gonna crash. Of course it does. It's C programming. Right. Oh, you called it. Segfault. No. No. So yeah, that's fine. I misunderstood my GPU library because I think there is a bit of a race condition with the upload stuff. Not gonna lie, anything about it. So I put it after, but really it kind of should go before the start apparently. But I think I need to put an extra thing in there to say we're doing uploading. I don't know. There's something wrong. There you go. It worked. That was so close. It was gonna be first time, but what can I say? It's got to suck for at least once. uh, yeah, if the compiler says okay, it must work. It's guarantees work. Contractly gonna work. Yeah. Yeah, kind of first try, right? First try when it worked. So there you go. There's the UI, guys, right? All you need is rectangles, yes? So there you go, look. We got a button. Cool. So what's the next thing we want to do? So we take a look at this shader, right? We kind of want to add some form of like alpha blending, right? Um, so, and we do kind of want to get all these different sort of things working as well. I don't know how many of these I want to do first, because obviously doing a glyph invite means something else. Some other system needs to be made, but we can definitely get some rounded corners, and we can definitely get some circle and maybe not a texture, right? But anyway. So so let's do two boxes, but this time the red one is going to be half transparent. And then we're going to have a green one that renders sort of underneath it. And then we're going to blend it. So with this mouth blending. So let's get into where we declare those things. This time we're going to have another one, which obviously is another box, but it's just going to go around the other way. And it's going to come after in the array, which means it goes behind it. We'll do render front to back. And the reason why we render front to back is an optimization, which means if the pixel is fully opaque, as in one or more alpha, right? Well, I mean like fully opaque, right? I mean it's not transparent at all. Just don't render anything else, right? And you can basically do alpha blending if it goes front to back or back to front. So this other one is going to be green, right? Because screw blue, right? Who likes blue? Or should we get pink, Perry? What was the Nah, pink and red. Nah, that doesn't go, does it? Fine, we'll do pink. Well, what was the pink color again? I remembered it. There was like it was really easy. It was like FFF. Like it was a really. There was a really easy way to do it. Because it's basically a let's pink and blue, right? Something like that. Have a bit of play. Yeah, nice gray. Yeah. Because that's pink. Is that my dark reader being like, oh yeah, make it dark pink? Good one. This is like baby pink. We want like a good pink, you know? Um, Color. Thank you, Google. So I think you can basically just say like FF 0. Wait, which one is that again? Oh, it's red. It's the wrong way around. Ah, too literal. Red, green. Alright, I guess you're purple. It's close enough. Yeah, it's close enough, isn't it? That'll do it. Right. So we're gonna just lower the blue. We'll give it 80 or something. Bit too ready then, isn't it? But yeah, I see what you're saying. Wait, 80 is too low, it's half. Maybe AA? Right, let's go with that one. So on the blue, we want CC. So blue is there. Voila. Cool. So we'll do a nice green here as well. So the pink is going to be a bit transparent, and it's going to be. We could make it. We could give it variable transparent, right? We can make it move. Yeah, let's animate it, right? Because you know it's not good if it's no right. So the basic idea is we'll have a number where you just call it alpha, and the alpha is just gonna go, you know, start 0, and we're just gonna increment the alpha by 1 every frame. We could do float, right? And that way we can control it and make it like a little bit less than that, right? And because computers are fast, right? And that'll just be like, you know, cause seizures. So, and we don't really have a delta time yet. So, anyway. And then the idea is we want to say draw command, so then we can turn it into an integer. Something like that. And then we want to like, then we'll say draw commands, 0.color. And then we want to remove the not the bits. Yeah, not the bits. 0, 0. There we go. Convert that to U32, please. Cool. And then we just all the bits on. Alpha U. Shift left 24. Voila. And there we go. Animation. Minus equal 1 instead of equal 0, because then it keeps the amount you've overflowed by. And there you go. So animation, and there's the green one. So if we render this now, let's not put a break here. If we render this now, we're going to get just pink, and then just going to get green. Wait, is that on top? It's the wrong way around. Too much. But they're good colors. It's like the Hulk, you know? Hulk UI. Yes, I have Zenity in my distribution. Oh. But also I have Google on my computer. Zenity color selection. Not bad. Pretty good, isn't it? Wait, can I what's this? Alias. Oh, you got it. On my wavelength. Save. Wait, I don't know how you do it. Alias-S. Yeah. alias dash s, and then we say color. This is fish shell, by the way, so it's a bit different. We're in business. You should have option not to add delta time to the graphics. Maybe. I'm not sure. It'll just go insane. It'll break things. We don't want breaking things. Right. So yeah, so it's assigning the color, that's the problem. It's just flat out assigning it. Right, okay. So I guess we will just do the alpha blending. So we could have just multiplied it, right? That's some form of blending. That's just gonna merge it. Right, it's just a multiply. But obviously you can't do it that way. You have to do mul f32 times 4 color, because it's C, right? And then if you run it, absolutely nothing. Why is that? Because it's black initially, right? So you start it off as white. So this is not good, but just as an example, right, of some form of blending, you get something like that. Why when you multiply? Wait, what's going on here? Why is that black? Is the alpha... The alpha can't be 0. Oh, the alpha's being animated. But then it starts off at 0. It's getting uploaded every frame. You would think... So we clear it out. Then we OR this one on. Oh, wait a minute. I meant 255. Sorry. I was thinking in normalized, but this is obviously right. Anyway, then we run it. Right, we need a print. Because clearly, Mino. Alpha equal F. Let's double check that's good, then we'll change it to the next one. Right, so that's going up. It's a bit slow though. Right, my computer ain't that fast. So maybe 1 is fine. We could be all day people. So maybe 5 is good. So you'd expect to see something there at least, right? Right? So dot color. So you zero out the last 2 bits, which is the alpha. Then we're saying or this shifted left. Mul just multiplies, right? So multiplies them together. So they should be... It should be fine. You'd expect the alpha to be set. Right, let's print out... Let's do the opposite, right? Let's say this... So that should be increasing, right? Yeah, that increases. So is my upload really working every frame? What is going on? So it's not very performant the way we're doing it right now, but we are going to do a more optimized version. Right now, per pixel, it's going to over every single draw command. And the more draw commands you have, the more it's going to fill up, and it's going to go. Every pixel runs the same draw. Every pixel runs the same draw command, even if it's not covering that pixel at all. But it does get to early out when it does draw stuff, which is kind of nice. Well, we are about to write that code, but there's an even better way to optimize it, which we'll get into. But yeah, I don't know how much better performant it is. You have to write both and test it out. But I think this one the performance could be quite good. Like, I don't think it's that bad. And it also depends on the hardware, right? If you run it on a desktop CPU, probably comparable. But a mobile, probably not. So the way we can test this, got our power render dock. Wait a minute, I've got to use the... Wait, I've updated my computer. But I don't have it installed, okay. So I basically had a patched build. Oh my days, what's going on? Five and 310. Yeah, I have no idea how to get that thing to build. We could try and build Renderdoc again. Get it up and running. Because I probably updated my system. And it's removed 310 basically. We've only got like Python 3.11. I could maybe just install... Too much Python, whatever. Yeah. Is there an easier way? There's probably an easier way to check to see if the upload is actually working, and that's just to change the color flat out the whole thing. So instead, we're just going to be writing. So it copies it a first time, then we copy it a second time. This time we'll just set it to white. Right, see if that works. Okay, so you saw it blink and change. So it is doing the uploads. But the question is, how much is it doing at the upload? So if we turn the red all the way off and then increment the color by 1, we should see it go to red. Wait a minute, sorry, I didn't do it 0, 0. It's only doing it for the first so many frames. The upload, and then is it not actually working? So it's only doing it for the first 2 frames and it doesn't work. Something like this. Oh, what have we done? Upload entries, and that's probably done in the GPU side. You submit, you clear that back to the beginning. See, it does a push, and if that overflows, it'll crash. So that's not the issue. So in the Vulkan backend, let's just quickly take a little bit of a gander. So right before we copy the data, place the barriers in, right, and then we do the barriers, copy all the uploaded data. So if it works for the first 2 frames, then it stops working on the third, for some reason. Or maybe we don't know for sure. Hmm. Yeah, this all seems fine. I can't see any problems with it. What are you passing in as draw command since it's done rendering? Since it's done rendering the rectangle. I'm not sure what you mean. Exactly. Is there a way you can rephrase that as well? The draw commands are just in a buffer, and we're just going over them per pixel. It's not the best yet. It should be fine. Yeah, so I don't know, what's an easy way we can test this? We can just say we can do a switch statement on the alpha incremented by 1. Right, here's the other way we're going to do it. We're going to change it between red, green, blue. We're going to say switch alpha u mod 3. And we're simply just going to comment these out. Take this, say case 0 equal to red. Break. Case 1, case 2. So this will be equal to, oh. Cool. Red, green, blue is going to like probably go pretty fast, but we should be able to tell if it stops or something else really. Sorry, I should have said don't look at the screen, but I guess this is a graphics stream, so it's going to show up, right? Right, so maybe we can, it's gonna get some effects, right? Wait, someone said to me a while back I should change my stream from 60 FPS to 30 FPS, just reduce. Have I got that down here? Yeah, I changed it down to 30, good. Because it made it easier for people to view. Right. So we are uploading and changing the color. So why oh why? So it was incrementing a number, right? and so let's get rid of this then. So it is uploading it. That is good to know. So let's start off at let's comment this one out for a sec. Just start off as 0, and we just wait a minute. You can't start off at 0. One, two, three, four, five, six. Beautiful. So alpha is on. And we're just going to start off by simply incrementing this by 1 every frame. So we should see red come on. It'll be black, goes to red. See, so it does work. This is what I want to see. Ah, but notice how it is black. Still. Maybe it is something to do with the way we just blended it for some reason. Right, so you're blending 1 times alpha is 1. This should all be a 1 in here, right? No worries. It's kind of a custom color scheme I'm using. It's based off of something else, but I then modified it on top of it. But yeah, basically. So the color scheme that I based off set the background and maybe set some color in a few places, but it wasn't fully good. So I just then took those colors and put it in tons of other places. Yeah, somewhere in the Discord it is, but if you want it, I can drop it in there again. So we're blending, we're is the multiplier wrong? AX times BX, AY times BY. But it won't be that on wait, should we check the spear V? Because yes. 2 seconds. Let's try a version where we just multiply it. By 111 and just see if it breaks it, because if it breaks it then it's something to do with that multiply. I'm probably doing something really dumb. Right, so it should be white, that's what we expect, right? It keeps the color. So right. So why is it black in the middle? You run over 2 rectangles that both have full-on alpha. Oh my days, it's not the alpha that's the problem. It's the fact that one is red and one is green. Yes, right, I knew it was in something dumb. Right, so obviously right, so that code will work. That's all we want to test is, does this code work? And it will. So we'll just change this from red. Yeah, we'll change this from green to red just for a second. So basically this has no green pixels. Sorry, the pixel or the color contains no green. and this contains no red or blue, which this has. So when you multiply them together, it clears the contents, right? Basically, contents gets cleared. Because this has 0 of that, and this has 0 of that, and that. So if we just move that around, that'll fix it. Right, so where's the alpha? Why are you not? Right, so summing up with the alpha now. Still. Thought that would have worked. Right. Maybe there's nothing wrong with it. So the pink one is drawn in the background, and we're changing the alpha of the pink one. Yeah, so the problem is it's kind of mostly red anyway. Yeah, you're blending. Well, there's no alpha blending happening. Right, so that value's been changed. Alright, we're good. We're good. Right, so let's do some proper alpha blending now. So that's just multiply. It doesn't obviously do anything good. So we need to blend these two pixels together, and also we're doing front to back blending, right? So the first one is the pink box, and the one that renders behind it is the green box. So I completely forget. Alright, so let's run it for a second. So this one we want to be behind. Wait, no, sorry. This one wants to be behind, this green one. This one wants to be on top. So you need to sort of blend the two colors together based on the alpha. Is it different? The equations at the bottom of the page. From the equation C alpha times AB. No, you can do float to int. There's little things for that in SpearV. You can reinterpret the data just fine. Right, so it's doing like color destination equals alpha destination. So let's see if we can get this. Let's see if this works, right? So color destination equals alpha destination Yeah, so apparently, I don't know if this is right. We'll try it out though. So you say multiply destination multiplied by yeah, we might do that. So color and alpha should be separate. Right, let's see how this goes. So let's just call this like C. Mol So multiplying scalar with s times 2 color.xyz wait, it's another s, isn't it? Color dot right, this make these variable names better. Source color, destination color. So what is this one? It's saying source color times source color alpha. So I guess RGBA, those all work. Doesn't matter. Multiplied by the destination color A. Then you want to just add destination color dot A, RGB. So add F30 times 3. So that gets you your color. And then the alpha, when you blend the alpha, is just going to be 1 minus source color alpha multiplied by destination color alpha, apparently. So hopefully that should be the correct blending. And then that will just, let me just construct that splat 3 C A, done. Right, see how that goes. What? What's my compiler complain about? Expected expression got comma. Right, something's up with the preprocessor. My preprocessor's a bit buggered. Damn it. Oh well. Yeah. Shoot. Well, I ain't fixing that. Cool, we just got a white screen, isn't that great? Because we started off as white. So start off as black as it should be. And there you go. Whoa-ho-ho. Incredible Hulk. So that seems to look right, doesn't it? I don't know, maybe it's going a bit too fast, but it is blending. So we'll make it a bit slower, because obviously my computer's too fast to add in numbers. Well, I don't know, it was a bit slow to be honest. It's adding 5 a frame. Let's go to 1 a frame. Does that look okay? Maybe we need to do multiple blends, right? To tell. Seems like it's going right now. Should we add another one just for showing off, or so the optimization we want to do, right, is like, hey, if this color ends up becoming fully So can we set this to 0, by the way? So we can't do that. It must start off as 1. But that's fine. So if we get a single pass on a pixel, and if color.a is greater than or equal to 1, then you basically just exit early. Right, you just end early. Very nice. So the idea is, right, so let's go ahead and turn the alpha off. Let's just imagine it's always on for a second. So this one's fully opaque. So we can describe what's going on. So here, so for these pixels here, it's drawing, it will iterate over every draw command. It will check, but when it iterates over the first one, it draws this box, or it draws the pixel for this box, and then it checks the alpha, and the alpha's like, this is fully opaque. And then it just ends early, so it doesn't bother trying to draw this one at the back. So, yeah, that's the optimization, right? Cool. All right, fair play. Yeah, it's called a vector. So float 32 times 3 is like a vector 3 in GLSL. So it's three floats. That's all it is. So this is 2 floats. Cool. So, what is the biggest problem? Wait. So should we get a couple of more things done? Like rounded ABB and then a circle. We'll get those in there. Those will be really easy. And then we'll talk about the problem, I think. So let's get a moving circle. Let's get a ABB which goes rounded and not rounded again. And that'll be a bit of fun, right? So the circle one's easy. Who knows their circles? So for the circle one, it's like the triangle one away, right? You do this difference between the center position. Wait, I got me a drawing thing. Right, here we go. Circle, center position. This is the pixel we're trying to draw. You take the difference, you get the vector between them. Okay, and you just check to see if the vector is the length of it. So the length, so you run the length operation on it. If the length of this vector is less than or equal to the radius, then yeah, then you're inside the circle. If not, you haven't passed, right? So the problem is we don't really have we have half size, right? So we don't really have like a radius thing, do we? Which kind of sucks. So so we could just say half size dot x and dot y is ignored. We could equally just do no, if we put the radius in both x and y, it still works. Right, because the radius is that and is the width and height, right? Yeah. So that will work. So what we're gonna do is go and add ourselves a ball. Perry's favorite shape. And we're gonna go. What color should we do now? I don't know the color. I need some random color, guys. Can someone pass me color, please? So we're going to have a position. We'll start off the center of the screen, and we'll just make it bounce left and right. We'll be updating that one. Half size, so we'll give a radius of 100. And then we're going to bounce. So let's get the X coordinate. Circle X. We'll start off at 400. And what we're going to do is we're going to say static boolean circle going right equal true. And we say if circle going right, we say circle plus equal 1 pixel per frame. Bit slow, because like 800 of them. So maybe say 3. Want a bit of boff. Alright, we'll do it. It's kind of like beef, but beef has a couple of O's in it. Or zeros in it. Nice. Thank you. We got it. So then else it's going to be a subtract. So I guess we could just do this, right? Who are we trying to fool? Now, if circle is less than 0 or circle is greater than 800, what we're going to do is we're going to then say circle is going right, not equals not circle is going right. So we're just going to flip that boolean and magic. So now we've got this little circle X. We're just going to draw commands 2, which is where the command is for the circle. And then we're just going to change that center position .x to be circle X. And there we go. So let's find the lovely circle. Where are we going? Right. So we took the difference between the center position and the current pixel coordinate. And we've got the difference. We now need to do a length operation. So I want to do it the yeah. So this is the unoptimized way, and I'll show you a more optimized way in just a second. And the distance is wait, is it going to be more optimized? I don't know if it is. Half size. Sorry. Less than or equal to half size. Why am I putting that in an if statement? It's a Boolean expression. Voila. So remember, as we said here, if the distance between the current pixel and the center position is less than the radius, then that is a pass. So let's give that a go. Where is there a length operation? Like where do we have that? Third party lib hmaths vectors. Oh, it's just called len. Right, our good friend len. Len. Right. Times 2. Beautiful. So if we run that, there it is. So it's kind of going, it's going behind as it should be. And we just got another pink there. Why did we get another pink? Why did you give me more pink? We didn't need more pink. Let's do a better color. I can't believe you just gave me more pink. Oh, you meant the other way around. Don't worry, I got you covered. Yeah, it is inverted, isn't it? Oh, you gave me more pink, but purple. Right. Okay, so the thing we want to do is like we kind of want that circle to be like on top of everything, right? Because that would be amazing. So we're just going to swap that around. All right. Use that one. OBB. BBO. Oh. What's going on? What? Why can't I? Why is it purple still? Why is that color? I'm hella confused. Why is that color not changing? One. Be fine. It's definitely a different color, right? But like, what am I doing? Right, okay, so it's changing. I guess it's changing, but it was very subtle. Right, so you flipped it around for me. I'll try that out. BB0EF. Maybe not. Right, we'll keep the yellow. Thank you for your suggestion. Anyway, so there you go. There's your circle. Isn't she beautiful? So it's bouncing left and right. You can need that for UI, right? You want your circle renders. That's pretty cool. So we could play around the alpha on that one as well, I guess. Confused about what is the color thing? No, it's not anti-aliased yet. Should we look into should we anti-alias it as well? That'd be a bit of fun. Yeah, we should anti-alias this. That's a good point. I do want to get to the optimization part, but and lines, yeah. Yeah, it definitely looks a bit horrible, doesn't it? So we get the mag. Oh wait, you don't need magnifier. Does this zoom in for you guys? Do you see a zoomed in screen? If you do, say yes, please. And it would be better if we see this without a. Oh yeah, that's good. Right, KDE for the win. Just press super plus and it just works. So I wanna. What am I doing? Let's not do the animation, right? The animation is cool and everything, but like, I can't see my AA. Right. So the problem with anti-aliasing, how do you do it? So can you see these lines, these pixels? Why did it go blurry? I don't know if that's good. We're better off taking a screenshot, aren't we? So if I then open this up in something sensible, like probably an image editor or something. Yeah, so let's open up Krita, you know, the Photoshop clone. Oh, that opened quick. They must have improved their load times. Good on them. Copy, new document based on the clipboard, thank you. Right, so you see here, look at this. That looks horrible, doesn't it? So how do you AA this? Good question. So you kind of want to, like, basically we just need to know how big is a pixel. Right? And we also need to know how close you are to the edge. And then if you are a distance from the edge, like you just need to smooth, like you need, yeah, you need to do something on it. So if you're in like a fragment shader, people usually use like DDX, DDY, and that gets you the derivative of the UV, or something like this. They typically use that. But we want to like, yeah, we're in compute shaders, so got to do it manually. So we do have the output dims, right? But we could have it pre-computed. But yeah, so you want to get the size of a single. Wait. Um. I think we're fine because we're working in pixel space anyway. Like the text just, you know, the. So I think it could be quite easy. Right, I just got to think how I'm going to do this. This is purely on the spot. So you have like your circle, and you got the distance from that to the pic. Imagine it's like a pixel right on the end. So the idea, imagine if it's here or something, and imagine we want to AA up to there. Like here you don't want to AA, but anything after here you want to fade out gradually, right? So yeah, it's kind of inverted. Yeah, it's kind of inverted the hex thing because it's stored back to front, isn't it? Alpha's in the high bits. Alpha's in the high bits. So I should have really put it the other way around. And I thought I did. No. So this is the point where it's fully on. This point where so I think people usually use lerp basically, right? So you lerp it. So you basically want to lerp where, right? So we've got a lerp function. So lerp just means obviously to linear interpolate between source color. So you just want to lerp the alpha, right? So you've got your diff. See, I was going to optimize that, but do I need the proper length? Yeah, I was going to optimize that where you do like a length squared. Yeah, so let's optimize this quick. Radius squared. So because we only need to check, yeah, but then it's gonna be in squared space when you do the lerp, isn't it? But then you just square the lerp t. You just square t. No, you can't. Yeah, let's not optimize this. Okay. Oh, you did it in lerp squared. You did it in squared space anyway. I messed up the first time. I did interpolation in squared length. It looks fine. Yeah, maybe it does look fine. But yeah, that's interesting. So you did the same thing. Ah, cool. Yeah, if you want to drop them in the Discord, thank you. It'd be good to take a look at those. I remember you showed me it before. I think you showed me before actually, but yeah, maybe they're there. That's funny. Same results. Yeah, so we have a length squared, right, which is simply just a dot product with itself. So it's like, so it's just doing it. It's not doing the square root. That's why it's faster. square root is kind of expensive. So to avoid the square root, you pre-square this, and then you're just doing a comparison, right? Because it's a bit of a the square of number b, and the square of a and the square of b have the same sort. The comparison between them, if they're greater than or equal to, stays the same, right? So that's the trick, right? You're avoiding an extra square root op. It's kind of only done once though, because this is this would be a scalar operation, right? It wouldn't be vectorized across all the threads, but still, it saves stuff. Okay. Then what else are we doing? Yeah, so this will work basically. Let's just try that again, right? Does it run? And then we'll do the AA thing. I need to get render doc working. I'll leave that up. So here we go. It still works. Ta-da. Next, we want to do the AA thing. So basically, we need to set the color. So we'll call this source color. We won't set it. We'll set ourselves. So this is for ABB for now. It's just unpack. But here we'll do this here. So we need the lens squared. As the radius grows bigger, the interpolation gets closer to linear. Right. Watch any shows? Yeah, we're currently watching the new Ahsoka. We just started that. Big Star Wars fan. We're quite happy with this stuff Disney's putting out on the TV side, but obviously the films they completely trashed that. But yeah. What else did we just finish watching? My mind has gone completely blank. We just watched that sort of like the sort of like thing on Netflix about Tyson Fury, his family and stuff. That was quite good. I enjoyed that. It was a bit of fun because I don't really follow like boxing much, so it's interesting to sort of get a view into that world. Yeah, it was interesting. Yeah, but we typically struggle find stuff to watch. To be fair, we go through a lot of stuff, but you know. But yeah. How about you? What's the stuff you're watching? I'll see if I remember anything. Lens squared. So basically, we just want to lerp. So lerp. So our color is a f30 4. So your destination. Which way around is it again? Yeah, start end. So source. So where's it starting from? So we kind of want to start from the source color. Wait, are we lerping the alpha only? Wait, 2 seconds, my wife is calling. I need to answer the phone. Be right back. Hello everyone, welcome back. So yeah, I just gotta double check something. Got kind of a bit of a situation, but hopefully nothing. The baby's got run out of food. Somebody's popped to the shop. But I need to see what time the shop's closed. Right, it closes at midnight. We're good. I can go to the shop after the stream. Isn't she beautiful? There we go. Right, so I need to get the chat back up on my phone. There we go. We're back. Okay. AA. Anti-aliasing. What does the baby eat? Is it still breast milk? Yeah. So we do pump the breast milk out and store it in the fridge, but it's kind of like he's been eating so much today. Definitely my son. So we kind of run out, and we keep some formula on the side usually, but we run out of that as well. So yeah. Yeah. So just one of them, which is a shame. So I'm going to let the alpha, source alpha to 0. Using, what is t? T is from 0 to 1, right? So that is source .a anti-aliasing. So what is t? So t is 0 to 1, and you kind of want to know, like, so you've got the radius, you also have the length as well. So you want to go from, radius is bigger, so you want 0. So you kind of do it the other way around. Yeah, okay. So you want to do smaller, take bigger in this case. Is that right? No, because that gives you negative. No. Flip these the other way around. Yep. So you want to do like a... I don't want you to call that. Just call it odd t. Good. Bigger, which is radius. Right, it's the radius of the circle. Take away the length. Is that what we want to do? Yes, that gets you the distance from the edge. Then you probably want to max it or min it at something. I don't know how to work out t. So 0 means nothing, and 1 will mean the alpha of this circle. So by doing big take small, right? The radius take away the length of the circle. Sorry, the radius, which is this guy, take away the length, which is from here to here. It gives you this line here, basically, right? This length here. So the closer it is to here, the smaller it is, meaning closer to 0, right? And the longer you leave it, okay, good. So essentially you want like how many pixels worth of AA do we want? And that's what we're probably going to min it against, and then divide it by that or something like that, right? That's my thinking about it. There might be a better way of doing it, but this is just on the spot trying to do AA. So you do get that distance between then what is the sort of like the number of pixels we want to do AA for, right? So we could just define a constant, define somewhere. Or just a constant. AA width. Let's say 4 pixels or something. I don't know. Maybe it's too much. Sweet. I'll take a gander. Thank you. I'll just write this out and we'll take a look. Then you want to do like a min. Right. So I think I have a min F32. So we take the minimum between this and this. Then we divide it by that. So that gives you a 0 to 1 number. Right. And then you put t in there and voila. So before we run this and take a look, I want to take a look at what Mr. No Idea has said, or has posted in the Discord. So he's done a software rasterizer for circles and squares and rectangles, stuff like that. So he's posted in art apparently. Yeah, I remember seeing this before actually, right. Right, so you've done... Wow, that's pretty good, isn't it? Yeah, it's like a line... Oh, yeah. That's really nice. Yeah, my AA is probably going to look different to this. Yours sort of does a... Yeah, mine will get blurry. Yeah. Is it because you're doing it line by line like that? Like, but then it even goes horizontally and so maybe it's not. Maybe it works similar way. Yeah, maybe that 4 is just way too big, but let's just take a look at it. That is pretty cool. Right. Did we even compile that? I think we did. No, we didn't. No, unreachable code. Expected basic typebook of void const. Grr. I don't want to mess with my compiler. Oh, I didn't even put... How did that go through the syntax tree analyzer? I didn't even put a type in there. Right. Okay. So that looks better already, I can see it. The agent squared space, okay. Not bad. Right, let's do a nice screen grab. Shoot. Give that a nice copy. Open up in Korea. Oh, come on, why is there black pixels? That's clearly wrong still. There's no AA whatsoever. Why is there no AA? Radius squared take length squared gives you a value between... Yeah, I don't know if that min is going to work or not. We'll see. I can try something different. I can say call. Oh no, I can't. I'm not sure if I've tested this min out, but I should have. No, Crete is free. It's open source. You can use it on Windows and Linux, and Mac probably. I don't know. Um, hmm. No, that looks pretty good to me. I think what else could we do? Wait, if I'm looping from 0 to 1 anyway. Yeah, let's just plug T in here and see how that works. So we just plug T in there. That's the equivalent of source alpha.a being 1, right? So if we plug T in there, we should be able to see something else. I'm just going to zoom in instead. It's going to be blurry, but I just want to see if the black pixels are there or if it's anything different. It still feels like it's the same, right? It's not AA'd properly still. So that's not good. So we could let's remove the min function and see if that changes anything. See if the min's broken it or whatever. Right, that's definitely looking like something is happening. Obviously anything over here is going to be greater than 1 alpha. That might mess with some blending or something, I don't know. But now let's take a screenshot and see if that helps. Oh, what am I doing? Oh, let's close this one. Right. Compared to the original, looks about the same to me. I'm not seeing anything really. Is there variable shadowing going on? Nope, it seems fine. So the coordinate is the pixel. Yeah. So it's rounded to the nearest. The pixel is bottom left or whatever it'll be. I don't know. I forgot now. Yeah, that's not the problem. But mate, should we put that in the middle? We should probably put coord in the middle. I'm not sure if this is going to fix anything. Wait, or should we? Yeah, we should probably put it in the middle. T computation is scuffed. What do you mean scuffed? I did remove the min just to see if the min was broken, but it's not. So, right, let's have a bit of a think. Oh, it is. That's it. The comma operator. Damn it, because it would have just did 4, isn't it? Right. Okay. Let's try that. That's a good idea. Right. It's just doing something crazy. It's flipping between colors. What? Why is it changing color now? Because the alpha will be greater than 1. Let's just say if t greater than... Because I don't know if that min thing works or not, right? I've not tested it. So So we've done a min right there. Wait, we're on 4, isn't it? Sorry. Oh no. Yeah, no, we're doing 1. Sorry. Okay, that seems good. So now let's take a look at that. Um, there's no AA going on whatsoever. So the next thing we can do is actually just do a color, right? We can instead encode a color. So the best way to do it would just be like, okay, if, and then we'll make it like something we haven't done yet. Maybe we just make it fully gray or white. Just make it white. So if t is less than 1, right, let's undo it fully to that. Min f32, whatever. So we'll say if t less than 1, we're going to say, okay, well, why don't you set source color to f32 times 4 s1. So that just sets every scalar component to 1. So we're seeing white dots, whereas we were seeing black dots before. So maybe that is see, I thought 4 was a bit too much, but it's a little bit too less for some reason. Let's double it to like, oh, let's make it like 32 and just see if we see anything. Four dots per corner. Yeah, it was weird, wasn't it? Yeah, it was in the corners. But now we're seeing it here, so you can see that could do some nice AA there, right? In a way, not super amazing, but something fishy's go. It is in squared space. Ooh, you got a better T. Let's see if we can decipher the no idea T. For someone with the name no idea, you do have the best ideas. It's kind of it's confusing. So let's decode the secret source. So the secret source is px. That's point xd. Wait, what is pxd? Oh, distance. This will make 1 pixel out of the circle. Anti-alias, right. There's probably this, yeah, probably this thing we've already got here, this radius. Divided by radius. Right. So what you're saying is, so is px underscore d, is that rate like the equivalent of radius squared, like this thing here? And then you're saying divided by radius plus 1 squared. Yeah, that makes sense. Pixel distance. Distance from what? Oh, it's the other way around. I see. Yeah, length, take that. Gotcha. Yep, gotcha. Right, then you're saying divided by radius. Right, and then you're going to square it. So what you're saying is like, that's 1 pixel. Right, let's sort this one out. Um, um, and then that gives you radius plus 1 squared take radius squared. There's no min there, we'll put that in there. Let's get rid of that. Well, let's comment that out just for a second. T Wait, should we do the trick? Yeah, let's do the trick so we can see if there's any white pixels. What's up with my T's? Need more of those parens. Right, now everything is white. So that's obviously not... Wait. Yeah, so I think yours is... Yeah, so I can... Okay, I see. I could have done it the other way around anyway. But yeah, I think yours is the other way around with the lerp parameters the other way around. So we should see black on the outside. Right, that's what we're dealing with. Is that right? Let's see any. Length squared take radius squared divided by plus 1 squared take radius squared. Hmm. T, because if t is less than, then we set it to 1. So, oh, it's the other way around. It was greater than 0. Yes. So that's why the thing was showing up weird. So it's only white on the edges. We don't really see any white on the edges. A bit wrong. So I want to then see... What could be wrong about this? See, I did add this 0.5. Maybe that's not good. I think this doesn't help. Because the other things don't add 0.5 to their center positions and that. So I think that could have been problematic. Okay, we don't see any white pixels in, which would indicate the AA thing. Yeah, something is definitely wrong. Should we check see if it's less than? T is negative. Right. So T is negative. Right, yeah, something's wrong there. Cool. Getting closer. Right, so we've done Yeah, I think that was... Yeah, I think that's correct now. Let's just double check if we compiled that properly. Alright. So we've got some black pixels shown up, which would indicate where the AA would happen. But it's not good enough. Let's up this to AA width in pixels, right? Let's up it to 32 just as a test. Did that compile? Something's fishy. I'll do a minus instead of a plus A and switch up the... Maybe I should remove that 32 thing I did as well. Same thing, not much. AA. Let's put the plus back. What is going on here? It's just all black. Right. Let me run over this maths. See what's wrong. So you got this radius take length that gives you the distance from, like, you're away from the edge or whatever. So it would take this picture here. You know, it gives you this distance, right? This vector. Oh, okay, distance because it's a length. It's a scalar. Then you're saying, okay, so I've got, you know, maybe this is at most 4, for instance. If any more than this, we'll just... Okay, no, so let's just say it's 4. So if that number is 4 and you've got basically radius squared plus 1, radius... So imagine the difference of that is like I don't know, say it's like 2. Well, in this case, it's like 32 pixels. Right. Imagine it's 32. It's probably more than that. So you're saying 4 divided by 32. So that should get you something above... Right. Like 4 divided by 32, that'll get you like something like 0. Yeah, 125. So... Right. And this condition here is saying draw white pixels if you're basically at 0 or less. Okay, so the closer... Yeah, maybe this is fine. This is working out fine, isn't it? I think it's just the coloring I'm doing is not actually helping. You need to render 1 more pixel at the edge of your circle in essence, increasing the rendering by radius by 1. Yeah, I'll put it back to 1 in a second. I just wanted to see something obviously appearing. But yeah, I think it's my debugging code, which was used there to try to help me, is not actually helping. So if that's like that was like 4/32, and obviously the closer it gets to 0, yeah. Yeah, so I think we should be able to chuck that in the lerp. But a way to visualize it, um, yeah, we just want to see t basically. So let's put it back to 1 possibly. Um, right, that just looks cool. What have we done? Um, there is an end waiting for the black pixels. Yeah, that'll take long, wouldn't it? No, yeah, luckily on GP debuggers, you can debug an individual pixel. You mean the pass condition? Oh. Oh. Right, that could be it. Or we could... Yeah, but do we want to render more than the edge? That's a good point. That just looks pretty sweet, though. I like that. That was good. That was a good bug. Right, I see what you're saying now. Right. So this pass condition here, we could instead use this radius plus 1 squared thing. Do you want to increase it by 1 though? Because you're saying it is an exact width. So maybe we do it the other way around. It's hard. It's hard, right? Which way is correct? Right. Okay. I'll do it. I'll do it that way. Okay. Right, so we have got a black thing around the edge now, and t is greater than 1. Yeah, so this is good. So t is great. T is greater than 1, meaning it is, and we saw that in the alpha channel, and it messes with the blending, basically, because it multiplies by the color, the alpha by the RGB color. That's why it makes that really crazy effect, and isn't that nice? So we should be able to pump that into lerp. Bearing in mind, I've got to get the lerp the right way round. So I think 0 in this case is swapped. I think. No. I swapped it around, didn't I? Ugh. What are you doing to me? We need to min it with anti-aliasing. Yeah, it's smoothing the edge out. So basically, it's like this. It's what No Idea shared, right? You're putting these little like transparent pixels on the edge. So when you zoom out and see it, it looks nice rather than having jagged, clear pixel edges, right? It's just a trick to make sure it makes it super jagged. Maybe we should do a clamp. What do we do? Um, One day we'll get there. There's someone else that's wrong now. So it's black at the edge, but it is transparent. Oh, it's gone into the negatives. Can you see there's some transparent layer? So that's correct. It's just it's now going into the negative. Is that really right? Yeah, it's looking good. So you want to like clamp it between 0 and 1. Let's do it. Oh, come on. What do we do wrong now? Mm-hmm. Did we compile it? No. uh... Mm-hmm. So you send the color to whatever the color is, and it should clamp between 0. So the circle is rendering first. That's what you got to realize. Um, it could be the blend function that's wrong. Should we get rid of the other stuff that we're trying to blend? Trying to do, right? We could reduce the count down to 1 and only draw the circle. Right, that looks AA'd. You can tell already. That looks like smooth. But let's get a good image on that. But so it could be something to do with our blending function is all. So let's open up a new clipboard. Whoa, look at that. That's good, isn't it? So it's blending it with black. Wait, you're blending. Sorry. You got the alpha, and it's blending. Yeah, it's blending it with black. Yeah, there's something wrong. There's something wrong with the blend function we've got, I think. So that's looking good. Because we're doing front to back rendering. Good point. Wait, what can I do front to back? What will be the problem? Um. Hmm. Yeah, because you need to blend over something. I thought you can do alpha blending front to back. But yeah, it'll be blending it with the. Yeah, so. Oh. Maybe because it's blending it with black first. That might be the issue. So the first pixel, and then afterwards you blend it. Would that work? So you simply set the first color. You got a possible idea? I like it. No idea. Hey there, programmer Jeff. How you doing? See, I want to keep front to back because then we can early out. Let's try something super hacky for a sec. Let's say like we know the first one's going to render. So let's just say if index equals 0. Just as a quick test, color equals source color. And then else we do this. Then we re-enable the other stuff. I don't know if this is going to work. That's why I want to test it. Right, that didn't seem to work either. I'll just set the source color equal to color, then yeah, definitely. Yeah, compute shaders. Custom C compiler, yeah. Yeah, custom C compiler for shaders, basically. Something like the color output of the shader needs to be blended with the background. The new alpha gets... Ooh. The color output of the shader needs to get blended with the background. So we're rendering all the layers. Yeah, so the thing is we're like per pixel goes over every draw command, right? This is obviously unoptimized right now. We're gonna optimize it in the next stream. So we're doing the blending in line basically. So this shader runs over every pixel. Oh, okay, this executes each thread per pixel, and per pixel goes over all the draw commands. So we're blending in line in the shader. So the hope is that we can just do it here. And because we do front to back, the idea is that if we hit a fully opaque pixel, then we're just done. But yeah, I think it's doing my blending is effed. So if you get like a 0, yeah, I want to try that black thing out for a second. So like, so the background, do I clear the texture? I clear the texture to black. So let's change the clear color. Change it to red, maybe. We change it to white. Let's do that. Right, so I cleared it to white. We obviously overwrite everything. Shoot. Yeah, then if I put the clear... Wait, what was it again that we wanted to do? Right, it doesn't work. That's going to keep it, isn't it? So if I start the color off as white, why when you blend... Yeah, something's wrong with the blend function. Because if we start off at white, with a white pixel, and then you come in here, and then you blend it, it should show... Yeah, something's wrong with this. So your source alpha, for instance, gets white. So you're blending. So you multiply the color by its alpha, then you multiply the result of that with the destination alpha, plus the destination color. Yeah, something's wrong here. We might have to. Yeah, this is wrong. So you could. So you might need to multiply. One minus. So I need to a one minus somewhere. I think that's what I need to do. So you got the source color, and then the destination color, which maybe say it starts off as white. Um, so if it's front to back, you can have a white pixel on top. Um, let's just use this one as an example. Well, that was bad. Where's the pencil tool? Right, so imagine you have like a white pixel on top. Yeah, it might be T. One take T. Yeah, one take A for alpha. Yeah. So you're going to be doing like this is already there, and then I want to put one of these sort of like brown colors there, for instance, instead. So maybe it should be fully transparent. Destination colors should probably start off as transparent. I don't know, we'll see. Let's figure that one out. So the color, at least, you want to say. So you're going front to back. So imagine you've already got a white color there. Maybe let's say it's fully opaque for this test. Wait, you might want to do a 1 minus here. So you multiply the source color. So this is the brown color by the alpha. So that'll be 1, for instance, right? And then you want to multiply whatever the thing is, that brown color, also by 1 minus destination alpha. Is that right? So if our white is fully opaque, you're going to multiply that one by 0. And then you add the other color, your destination color on. I think that makes sense. And then you blend the alphas together. So to blend the alpha together, you say, I think this might be right. We'll see. So my which is 1, and then that obviously be times by 0. Because your source color is 1. Source color 1, which would then make is, yeah. Wait a minute. So the example is if this thing is fully opaque. Like if that white pixel is fully opaque and you've got this brown pixel coming in with an alpha of 1 as well, and it's behind it. This is just the example. We'll change it the other way around in a second. If you do one take source, like that will give you 0 times 1. And that you don't want, so the alpha that you'll be using from here on out will be 0. And that's kind of correct, I think. So I think that's fine. Let's run through the example of what happens if this white pixel is actually transparent, like fully transparent. So you'll do brown color times by 1, gives you the same color. Then you'll do multiply by, obviously 1 takes 0, which would be 1, so that'll be on. And then plus destination color RGB. That doesn't make sense though. Do you want, like, what happens if that RGB is, that definitely needs to be multiplied by, see, I think this needs to come out here. Is that right? No, because that's already pre-multiplied, isn't it? That's already, is it pre-multiplied? Yeah, that would already been pre-multiplied with the alpha anyway. So you leave that alone. Cool. Yeah, I think that works. So instead we'll start off with pure zeros here. I think that's the fix. Let's try it out. It's getting closer to white. Maybe I'll get something. Alright, maybe that ain't good. So we simply just changed this the way around. So it was kind of working fine, but then it... Oh, no, we started off as 0, didn't we? So we started off at everything on 1. What happens? Yeah, we'll keep the white, obviously, wouldn't it? So let's change it. Let's just make the alpha 0, see what happens. So maybe you do have to multiply. You know what, I'm just going to Google for an answer. That was me trying to work it out. Front to back, alpha blending. Let's try that. Search for OpenGL or something. I tried my best. And it's nearing the end of the stream, so let's just... Yeah, whip out ChatGPT, you know? Right, back to front revisited. To front to back, we need the usual things. Initialize the color to all black, translucent. That's what we was thinking about doing, right? Done. Wait, it's not the background. Yeah, maybe that is, I don't know. But anyway, we set the blend function to 1 minus destination alpha 1. This means that the new layer is dimmed to be the remainder of the opacity. I need to figure out what that is in OpenGL speak. I forgot. We need to pre-multiply our fragments RGBA with its alpha. Yep, so we already do that. Then it's 1 minus destination alpha. So that seems like we already do that. And then it's 1 on the alpha. Right, I think I'm not keeping the alpha. There's something. Oh. Maybe this is wrong where it keeps the alpha. It's getting quite close, I think. So they put 1 in here, which means it's probably saying 1 times. It's probably just saying, it probably just blends it like that, I think. Hey there, welcome to stream. I can't even pronounce your name. Welcome. Thank you. How would you pronounce your name? This means that the new layer is dimmed. We need to pre-multiply alpha by its alpha because this is being done by the... This isn't being done by the blender anymore. Okay, so I think that could work. Maybe it won't. It's worth a try. No, same thing, same problem. It's going to white. It's blending to white. Right, let's look for that OpenGL blend mode function. There's a blend mode function, right? I just want to see the so it's not the separate one they're talking about. They're talking about like blend. It's not separate. They're talking about, so it's the same. Yes, the alpha might have to work the same. They're talking about. Wait a minute. So the separate one separates the color from the alpha. So you have a separate one for each. A separate sort of equation for each. So it's saying destination times by 1. Source times by 1 minus destination alpha. So if that's already what we've got, right? It's pre-multiplied. Source color, so let's pre-multiply that. Source color equal that. I found one liner for blending which is called Porter's Duff composition. The article is German only though, maybe it works. Have you got a link for that? Thank you, Fabulous Flow. I had one function for alpha and the other color in software rasterizer worked fine. Oh yeah, to keep it the same. Yeah. Let's see. Yeah, maybe it will work fine. Yeah, that's what we're gonna try and do here is just do a single one. Hopefully it works. So we pre-multiply the alpha. Source alpha. So we kind of want to achieve this, but for A. So obviously it can just be a simple version of it. 1 minus... Shoot. Plus... that, right? Oh... RGB. RGB. Is that working? That's looking pretty good to me. Did we just nail that? Please. That's looking AA'd. And the color... Oh. Should we get a proper screen grab of that? I can't believe we did it. See, I find blending like way easier. When you handwrite it, I always hated those blend functions. I always have to like write the thing out, just so I can figure that stuff out all the time. Full screen, please. Thank you. Copy. What? It's not the right one. There we go. Right, is that AA'd? Oh yeah, look at that. Oh, in with that purple. That's or pink. That's what we want. So thank you there for the help there. No idea. And also sidetracked to me as well. That's fun. But I'm glad. So we need to do that for the boxes as well. This will be way easier. So yeah, it doesn't really hit up there though. It's a bit. That looks good though. Yeah, I would not have thought of done AA if it wasn't for the suggestion though. I would have saved that till much later. That's really good. Yeah, it makes my graphics look better. He knows everything. It's funny because it's called No Idea. It's like he has no idea at all, but really, he can help you with everything. So we can obviously AA the box as well, which will obviously look way better. We can obviously start moving this thing as well. But yeah, so things are looking really good. I don't know if we want to do a texture. We could do a texture. I can get the logo in here. But so we could get the texture and maybe glyph done actually. You're right. I think we want to do that start next stream, and then after that we'll do the optimization because we have a good. Like these are gonna be quite quick to do. Like they're not gonna be they're gonna be like super quick. So we'll start off by AAing the bounding box. We'll do a rounded AABB as well because you want those lovely curved boxes. We'll do the texture, do the glyph, and then we'll do the optimization. That'd be super sweet. Have no fear, no idea is here. We need to have like the no idea signal. Just sort of like the bat signal, but on the screen, you know. Yeah, I think those won't be too bad to do. Like the glyphs, we'll just grab like a pre-rastered, like 8x8 terrible font just for now. And it's something. Just an ASCII pre-rastered font. Throw it in there. This will probably be a sign distance field, this AABB rounded. And yeah, doing the AA now will be easier because we actually have a proper blend function. What else are we missing? Oh, I wanted to re-enable the movement of the box, didn't I? Look at that. Oh, isn't she beautiful? Doesn't that look way better? Oh, those 2D graphics. Yeah, it is a sign distance function. That's right. The circle is definitely. And so is the box, actually. The box is 1 and 2. It's just the easiest way to do it is sign distance. But yeah, I'll be doing the rounded one as well. I've got to go and grab that from somewhere because I'm not that smart. That's incredible. So obviously, guys, as you can tell, the only time of when it's optimized is when you draw something opaque on a pixel. But we've got to make sure that say we have like 1,000 things that we draw on the screen, it's not going to be optimized, is it? Because, well, yeah, it won't be optimized because you'd have to go over the list until you hit the pixel, which is for your, like the draw command, which overlaps your pixel. And that could be ages. So think about that and think about how we could fix that because that's what we'll be doing next stream in the optimization. Right, let's find somebody to raid because I need to go to the supermarket and get my baby some milk because he is gonna milk. Welcome, Crimson Mania. Good to see you. But yeah, that was a really good stream. I really enjoyed that. That was quite successful. I was hoping to get further as usual, but that was good progress. That was good progress. I like it. I like it. Any C people? Do I see the CP? There's a CPP guy. We could raid him. I want to see if there's any more Messi bros. Bum 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 bum. Another CPP guy. Custom multiplayer maps. Woo. That's funny. Let's raid that guy. Let's make this guy happy. Right. So I got a bit of an announcement. There's no stream on Sunday. I'm throwing a party. So unfortunately, it's in the physicals. So anyway, and it overlaps with the stream, all that jazz. So next stream is actually on Tuesday. So yeah, you'll wait for the surprise of how we're going to optimize this thing. But yeah, I'm sorry guys. Sorry you're not invited. Yeah, it's a shame. But you are invited to the next stream, and the stream after that, and the next one, and the next one. But yeah, that's about it. Feel free to join the Discord. And if you have any questions, check that one out. Right. Have a good weekend, and I'll see you all on Tuesday. Bye bye.